Welcome to today's tutorial. So in this tutorial we're going to discuss implicit functions, and if you have not yet subscribed to the channel, make sure that you do so. And if you have any questions or contributions or corrections, you can send them through these lines on the screen. Okay, so what is an implicit function? Okay, so we know to say functions, or rather let me say equations. Okay, most equations that we know are always in this format. We know that y is always raised to the power 1, and then x this side is mostly raised to the power n, let me say n plus any number. Okay, let's say if you have, I'm just giving an example, we can have this function y is equal to x to the power 2 plus maybe x and then plus 1. This one we call it a quadratic function. And then any function that has, we call it a quadratic equation, and then any equation that has the degree of x here that has been raised to more than 1, or where this n, let me call this n, if this n, we say n minus 1, then we say plus x, n minus 2, then plus, we do this. So if this n is greater than, if this n, the power of x, is greater than 1, we always call that to be a polynomial. Yeah, so now for implicit equations, or for implicit functions, or implicit differentiation, when we talk about this type of differentiation, we differentiate functions which in which y is also raised to a certain number. So y will also be raised to a certain number, which can either be 2, 3. It can be 1, 2, 3 going up. Yeah. So let's say I'll put the power of y here as m, and then we say y to the power m is equal to x raised to the power n, and then plus this can be x raised to the power n minus 1. This y is also going to have a power, in short. That's what I'm trying to say. So now, how do you differentiate such functions? So I'm sure you know how to differentiate functions using the power rule, chains rule, product rule, and quotient rule. So we're going to be using those rules to differentiate implicit functions. So if you have, let's say for instance, the function y is equal to x squared, then they ask you to differentiate this, or to find dy dx. So finding dy dx of this function, you use what is called the power rule. So this will be dy dx. So this will be dy dx is equal to, so when you differentiate x squared, you drop down this x, or you multiply it to the coefficient. So this one, we know that the coefficient is 1. So 2 times 1 there, the answer is 2. Then x, you have x there. Then we say 2 minus 1. So 2 minus 1, the answer is simply just 1. Hence the derivative of this equation there is simply just 2x. So this is how you differentiate using the power rule. So now imagine that y is also raised to a certain power. So if y is also raised to a certain power, you have something like this. Y is equal to, let's say you have y squared is equal to, maybe you have x, let's say x squared as well, then plus 1. If this is what you have, or let's forget about this one first. Let's just say y squared is equal to 1. Rather, y squared is equal to x. So if you want, you can first square root both sides. So when you do the square root of both sides, you're going to have x is equal to plus or minus the square root of x. This is what we're going to have, meaning you have two values of y. You have y1 is equal to the square root of x, and y2 will be equal to negative the root of x. Yeah, so if this is what you have, you can now differentiate them independently. So you're going to have, when you differentiate this using chains rule, you have something like this. Let me just do one direct, and then the other one will be step by step. Okay, let me start with the one that I'm going to do step by step. So this one can also be written as y is equal to x in brackets, then we say to the power half, because any number that has been square rooted is just the same as that number to the power x. So this x, the square root of x, is just the same as x to the power half. So when we multiply this half times the coefficient of x this side, which is 1, we're going to have our dy1 dx to be equal to, so first of all we have half, and then we write this x. Then when we say half minus 1, so half minus 1, the answer will simply just be negative half, which is just the same as saying dy1 dx is equal to half. This will just be equal to half, and then down there you have the square root of x, because if you have a negative there, it's just the same as taking x down. Yeah, so in other words, what I'm trying to say is this part here is just the same as saying half, and then it's just the same as saying half, and then over x to the power half. But remember, any number raised to the power half is just the same as the square root of that number. So this is how I came to this. Yeah, so which implies that even this other one, this side, will just be straightforward to be y2 is equal to negative, the only difference there will just be the negative, to be 1 over 2 root x. Yeah, so this is how you do the normal differentiation. So now if you are using implicit differentiation, it means that you have to do this. You're going to say we have this function here, we have y is equal to x, we have y squared is equal to x. So if you're using implicit differentiation, it means that we're going to differentiate this y the normal way we differentiate x. So when you differentiate this, means that we're going to say 2 times the coefficient of y this side, it will be 2, and then we have y, and then 2 minus 1, the answer will simply just be 1 this side. Then we say dy dx. So every time you differentiate y, you always have to add dy dx when you're dealing with implicit functions. Then this other side, when you do when you find the derivative of this part, so this other side, when you find the derivative of x, the answer will simply just be 1. So to find dy dx, we simply just divide everything by 2y, so that we just remain with dy dx on this part. So we're going to have 1 over 2y. So if we have this, remember we have y squared is equal to this, so now is equal to x. So now to find y, because we need to replace this y with a function of x, so now to find y, we're going to say y is equal to, we square root both sides, meaning we're going to have plus or minus the square root of x. Yeah, so this is how you do implicit differentiation. So now we're going to replace this plus or minus the root of x there where there is y. So we're going to have the solution to be 1 over 2, then we say plus or minus the root of x. So this is what we're going to have, meaning the solutions to this equation, or the derivative of this equation, will therefore be equal to, the first one will be dy, let me say dy dx is equal to, this is the first solution, dy dx is equal to the positive of that, so that will be 1 over 2 times the root of x, and then the other dy dx will be the negative of that, which will be, let me write it down here, dy dx, which will be 1 over, it will be negative, of course, negative 1 over 2 root x. So this is how you do implicit differentiation. So let's quickly move on to practical questions. Let's look at some questions in the book. Okay, so the question is find dy dx by implicit differentiation. So how do you find this dy dx using implicit function, implicit differentiation? So we have the first question there, which is a. So the first question there, a will be x squared plus y squared is equal to 9. So we differentiate this x the normal way. So how do we differentiate this? The answer will be, so 2 times the coefficient of x there, which is 1. 2 times 1, the answer will be 2. Then x raised, we have x there. Then we have 2 minus 1, which is just x. Then the other part, which is this part, will simply just be, when you differentiate this one, remember what I said, every time you differentiate y, you always have to add dy dx. So we differentiate this the normal way. 2 times the coefficient of y there will give us 2. And then we have, we're going to have y raised to the power 1, because 2 minus 1 is 1. So after differentiating y, we always have to add dy dx. Then this is equal to, the derivative of a constant is simply just 0. Okay, so yeah, so the derivative of a constant is simply just 0. So here it's just a matter of making dy dx the subject of the formula. So I'm going to take 2y to the other side of the equal sign, so that I remain with, 2x, I'm going to take 2x to the other side of the equal sign, so that we remain with 2y is equal to, 2y dy dx is equal to negative 2x. Then I'll divide everything by 2y, meaning my dy dx will simply just be equal to, these 2 and that 2 cancel, just have negative x over y as the solution. But remember, we can't leave it like this, we have to replace y there. Okay, so if you want, you can leave it like this, but depending on what or how your lecturer want to present your work, you have to finish it up if they want you to finish it up. So this y, remember, from this expression that we have, we can make y the subject of the formula. So we're going to have y squared is equal to 9 minus x squared. So now, to make y the subject of the formula, we're going to square root both sides, so that we have y is equal to the square root of 9 minus x squared, meaning the final expression for dy dx is simply just going to be dy dx is equal to negative x over, while there is y there, I'm going to replace with that. So this will be the square root of 9 minus x squared. So this is the derivative of the first question there. So the same way I've done this one, that's the same way you also do this one as well. So it's not something that is difficult. The only difference here is the sign in between and the number this side, but otherwise you follow the same steps that I've followed here. In case you have solved it and you are doubting, you can solve it and then capture the solution. Then after capturing the solution, send it to my WhatsApp line. I'll tell you whether it's correct or wrong. Okay, so let's look at this one. Okay, so for C we have x to the power half, which is just the same as the square root of x, plus y to the power half, which is also the same as the square root of half. So we have x to the power half, this is part C, x to the power half, then plus y to the power half is equal to 16. So if you have such an expression, then you want to differentiate it, you use what is called implicit function, because y has been raised to a certain power. So what we are going to do is this: if I want, I can first take this x to the other side of the equal sign, so that I just remain with y this side. So I'm going to have y to the power what? To the power half is equal to 16 minus x to the power half. And then, yeah, but if you want, you can first differentiate it and then take everything to the other side of the equal sign, so that you just remain with dy dx this side. So let us differentiate y to the power half. So differentiating this will be 1 over 2, and then, because when you multiply this 1 over 2 times the coefficient of y this side, which is 1 over 2 times 1, the answer will be 1 over 2, and then we say y, then we have half minus 1, the answer will be negative half. So half minus 1, the answer will be negative half. And yeah, so I was saying in the previous solution that we had, there was this question here. You are supposed to, when you find the square root of any number, the answer is supposed to be a negative and a positive. Hence, the answers were supposed to be 2 in this first question that I gave. So you are supposed to find the 2 answers. So the first answer was supposed to have a positive in front, because when you replace y here, when you find the square root of y, then you replace y where there's on the denominator there. Okay, let me just write the solutions here. So the first solution was supposed to be dy dx is equal to negative x over the square root of 9 minus x squared. Then the other dy dx was supposed to be x over the square root of 9 minus x squared. I don't know if I wrote this because I've erased, so I've forgotten if I wrote them. Okay, so these are the solutions that were supposed to be on this one. Otherwise, all the procedures, the steps were just okay, except when writing the final answer. I think I just wrote one answer for the negative. You're also supposed to write for the positive, because after square rooting a number, the solutions are always 2. Yeah, so let us continue. Let us proceed with this one. So we also differentiate this other side. So differentiating this other side, the derivative of a constant is simply just 0. Then the derivative of this will give us, so we have negative 1, which is the coefficient of x, times half. We're getting negative half. Then we say x, then half minus 1, half minus 1, the answer is negative half there. So we can now, this part I forgot to add dy dx, sorry. I'm supposed to add dy dx on this one. Okay, so we can make dy dx the subject of the formula. So when you make dy dx the subject, you are going to divide, you are going to divide everything by a half to the power y. So before we can do that, if I want, I can change this first to a normal, what's this? I can change this. So if I want, I can change this. So this will be 1 over 2 the root of y, because any letter or any number raised to the power half is just the same as the square root of that number. So the root of y, and then this will be equal to, this dy dx here, of course, and then this will be equal to, this side are also remaining with negative half over, so let me say negative 1 over 2 root x. So when we find dy dx by making it the subject, this is just going to be equal to, when you cross multiply, you're going to have negative 2 root y over 2 root x. So our dy dx will therefore be equal to, so dy dx will therefore be equal to negative root y over root x. But remember, we have this expression, we have to make y the subject, and then we replace it there. So depending on how your lecturer wants your work to be, you can either leave it like this, or you make y the subject there and replace it there. So if they want dy dx to be a function of x, you always have to make y the subject there. So if we make y the subject, we have y to the power half is equal to, we're going to have 16 minus x to the power half. And then from there, we can square both sides to get rid of the half. So when you square both sides, you're going to have y is equal to 16 minus x to the power half. So x to the power half is just the same as the square root of x. Then we have this squared. So we can replace this value of y while there is y there. So our dy dx will therefore be equal to, while there is y there, I'll replace that. So I'm going to have negative the square root of what? 16 minus the root of x, and then squared, and then everything over the square root of x. So this and that will cancel. So what we just remain with is 16 minus the root of x, then everything over the root of x. So if you want, you can rationalize the denominator of this expression so that you can just have the answer which is not going to have the square root of a number, which is not going to have a radical down. Okay, so let's quickly move on to the next question. So the next question is this one. Yeah, so the next question is this one, which is also similar to what I've been doing. Anyway, let's just do it. Okay, the next question is 2x to the power 3 plus 3y to the power 3 is equal to 64. So this one, if you want, you can also first take 2x to the power 3 to the other side of the equal sign and then differentiate. And then if you want, you can just differentiate it like this. So when you differentiate the first part here, this will give you, so we multiply 3 times 2, we get 6. Then we have x to the power 2, because the power reduced by 1. We're using the power rule to differentiate. So we also differentiate this part. When you differentiate this part, we're going to have 3 times 3, that will give you 9, then y to the power 2. But since you've differentiated y, you always have to add dy dx, because this is implicit. And then the derivative of a constant there will give us a 0. So we take this 6x squared to the other side of the equal sign, so that on the left we remain with 9y squared dy dx. And then this is equal to, when you take it to the other side of the equal sign, you have negative 6x squared. So we divide everything by 9y, so that we remain, 9y squared, so that we remain with dy dx this side. So dy dx is simply just going to be negative 6x squared, everything divided by 9y squared. So this is our dy dx, which can be reduced further to dy dx is equal to negative 3 into 6, 2, 3 into 9, 3. So this will be negative 2 over 3, and then we have x squared over 9 squared. So this is what we have as our dy dx. So you can either leave it like this, or you can simplify it further by making y the subject of the formula there. So when we make y the subject of the formula, we're going to have, first we take this 2x to the power 3 to the other side of the equal sign, so that we remain with 3y cubed this side is equal to 64 minus 2x cubed. So we divide everything by 3. So when you divide everything by 3, and then we're going to have something like this: 64 minus 2x to the power 3, then everything divided by 3. Then we make y the subject, meaning we're going to have the cube root of everything this side, which will be 64 minus 2x to the power 3, and then everything over 3. So now this part is what we're going to replace while there's y here. So we're going to have dy dx as negative 2 over 3, negative 2 over 3, then negative, let me say negative 2x squared, then over 3 times the cube root of 64 minus 2x to the power 3, then everything over 3. But of course this has to be squared, because y is squared here. So this is the solution for dy dx. So implicit differentiation, once you just practice, so if you're just practicing, it becomes more easier and simpler the more you practice. Okay, so let's move on to the next question. So we have e, which is just x cubed minus xy plus y squared is equal to 7. So let us differentiate independent terms with respect to x. So when you differentiate x cubed with respect to x, the answer will simply just be 3 x squared using the power rule. Then this one here will not differentiate it the way we've been differentiating other functions. For this one, we're going to use the product rule, because we have two functions here and we're differentiating them with respect to x. So the first, when you're differentiating two functions, let me differentiate it independently here, and then I'll just come and replace it in the solution. So I have x, so I'm having x and y, and then I'm told to differentiate this. If this is my function, then I've been told to differentiate this. I'm going to say, okay, let x be equal to u and v be equal to y. So if you want, you can say let u be equal to x. I want to show you how to use the product rule in case you've forgotten, and v is equal to y. So the first thing that you need to do is to find u prime, which is just the derivative of x there, which is 1, and then you also find v prime. The derivative of y with respect to x is simply just going to be 1, but not only 1, because we're differentiating y, we're going to have 1 times dy dx. This is what we have. So now the product rule states that dy dx is equal to v u prime plus u v prime. So we can replace it in the function, so in the formula. So we're going to have v, our v is y, times u prime is simply just 1, it's this one here, and then we say plus, then our u is x, and then v prime is dy dx. Okay, so now we can replace this expression, or we simplify it further. This will be y plus x dy dx. So we replace it there. So we have negative. Whenever you are replacing, I always encourage to put everything you are replacing in brackets. So plus, then we have x dy dx. Then we have plus. When you differentiate this part, this one will give us 2y, because when you because you're differentiating y, you always have to add dy dx. Then we say this is equal to 7, but the derivative of 7, the answer is 0. So we can simplify this expression. This will be 3x squared negative y negative x dy dx. And then we have plus 2y dy dx. And then this is just going to be equal to 0. So now we can factorize dy dx. So let's take all these first to the other side of the equal sign, then we factorize dy dx, so that we make dy dx the subject of the formula. So this side we're just going to remain with negative x dy dx, then plus 2y dy dx. Then this will be equal to, when you take everything to the other side of the equal sign, you're going to have y minus 3x squared, because y is negative when it comes this side to be positive. 3x squared is positive when it comes this side of the equation to be negative. So we factorize dy dx because it's common between these two terms. So in factorize dy dx, we're going to have negative x in brackets, and then plus 2y. Then we say this is equal to, on the right this side we have y minus 3x squared. So now after doing this, we can now divide everything by, so we can now divide everything by negative x plus 2y, so that we just remain with dy dx on this on the left. So our dy dx will now be equal to Okay, so our dy dx will now just be equal to, so when you divide everything by negative x plus 2y, we'll just have y minus 3x squared, everything divided by negative x, then plus 2y. So this is how you differentiate such a function using implicit differentiation. So it's not something that is very difficult to do. These are straightforward questions. Okay, so now that you know how to differentiate these, I'll just be explaining how to differentiate them. Then those that look a little bit tricky are the ones that I'm going to be solving. So for this one, when differentiating these two functions here, differentiate them the way I did the way I differentiated this part. How? By using product rule, because you are multiplying two different functions and you're differentiating them with respect to x. So you differentiate this part, even this part, in a similar way I differentiated this one. Actually not similar, but in the same way. Yeah, you follow the same steps. Then even this one you use a product rule to differentiate. Then for this one you just differentiate it the normal way. Okay, I think let me differentiate this one, because when I differentiate this one, I guess this one will be easy. So we have x cubed, y cubed minus y is equal to x. So differentiating this first part here, we say our u will be equal to x cubed, and then our v will be equal to y cubed. Okay, so y prime will be equal to 3x squared, and then v prime will be equal to 3y squared, but of course we're differentiating y, meaning we have to add dy dx. So this is we write now the derivative using the product rule, because we know that the product rule states that dy dx in terms of u and v is simply just v prime u plus u prime v. So you can either start with u prime v plus v prime u, you still get the same answer. But if you are dealing with quotient rule, the quotient rule, you always have to start with v u prime, yes, and then followed by minus u v prime, and then you divide everything by v squared. But in this case, this is a product rule, and addition, we know that addition is commutative, hence you can start with any. So we replace these solutions in the formula there. So v prime simply just 3y squared dy dx, and then our u simply just 3x squared, and then we say plus, and then u prime is simply just 3x squared, rather u is supposed to be x cubed, not 3x squared. U is x cubed. So, yeah, so we have 3x squared as u prime. 3x squared is u prime, and then the value of v is simply just y cubed, so you also add y cubed to this side. So this expression we found here is what we're going to replace there. So we're going to have 3y squared dy dx multiplied by x cubed. Then we say plus, we have 3x squared, and then y to the power 3. Then we say this, sorry, not equals but minus the derivative of y, simply just dy dx. Then you also have this part here, which is x. When you find the derivative of x, the answer is simply just 1. So we can take this to the other side of the equal sign, and then we factorize dy dx. So when you factorize dy dx, we're going to have dy dx, open brackets, in brackets we're going to have 3x cubed y squared, 3x cubed y squared, and we say minus 1. We're factorizing this term and this term there, minus 1, and then this will be equal to 1. When you take this side, this part to the other side of the equal sign, you are going to have a minus 3x squared, then y to the power 3. Then when you divide everything by this expression so that you remain with dy dx this side, your value of dy dx is simply just going to be equal to 1 minus 3x squared y cubed, then everything over this expression there, which is 3x cubed y squared minus 1. So this is exactly what you're supposed to find as your dy dx. Yeah, so it's very simple and straightforward. It's not something that you have to even take time to solve. Okay, so since I've solved this one, I'm sure this one will be easier. So I'll not solve this one. If you want, you can solve it on a separate paper, then send the solution on WhatsApp. So even this one is straightforward, because the only trick part on this question, this part is straightforward, this one is straightforward. The only trick part is this one, but you know to say the square root of x y is simply just equal to x y, everything in brackets, raised to the power half, which can further be distributed as x to the power half and y to the power half, and then you differentiate this. This one is now easier to differentiate. You differentiate it using product rule as well. Then you come and replace it in the function for the derivatives. So this one is also straightforward. Differentiating x to the power 3 is straightforward. Here you use product rule. Even there you're going to use product rule. Okay, let's take a look at this question. Okay, so for this question here, we have, this is J, we have 4 cos x sine y is equal to 1. So differentiating this part, this we're going to use, differentiating these two functions, we're going to use what is called the product rule. Yeah, so we're going to use the product rule, and since this is implicit function, we also have to understand that after differentiating sine y, we have to add dy dx. So using the product rule, we're going to say let u be equal to 4 cos x and v be equal to sine y. Okay, so differentiating this part, differentiating u or finding u prime, we differentiate u with respect to x. When you differentiate cos, you always have negative sine x, but because there is a constant outside there, it always has to remain. The 4 is outside, so we always have to leave that 4. Then we also let me first finish this one. So u prime will be equal to negative 4 sine x, and then let us also find v prime. So v prime will be equal to, the derivative of sine y is cos y, but because we're differentiating y with respect to x, we always have to add dy dx. So the final solution for this one will be v prime is equal to dy dx cos y. So now we replace the two solutions in the formula. The formula is dy dx is equal to v u prime plus u v prime. So we replace the whole expression, the two expressions in the formula. So what is our u, our v? Our v is sine y. So I'm going to put sine y there. And then u prime is negative 4 sine x. So we have negative 4 sine x. negative 4 sine x, and then the other part we have is u and then v prime. So my u is 4 cos x, so I say plus 4 cos x, and then v prime is dy dx cos y. Then we have dy dx cos y. So now we can replace this expression after simplifying it. I'm sure when you simplify it, we'll have something like this: negative 4 sine x sine y, negative 4 sine x sine y, then plus this part will be dy dx, then we have cos x. This part will be dy dx, then we have 4, we're going to have something like 4, then cos x, cos y. So now, this is what we have. There's supposed to be dy dx somewhere. I can't see it. Yeah, I wrote dy dx here. So there's supposed to be dy dx here. Okay, so after finding this expression, we can now replace it in this. So the derivative of this whole part here is simply just, let me demarcate, simply just going to be this expression that we have there, which is, so I'll say negative 4 sine x sine y, then we say plus dy dx, then we have 4 in brackets, have cos x cos y. Then when we differentiate 1, the answer is simply just going to be 0. So what we do here to make dy dx the subject, we're going to take this part to the other side of the equal sign, so that on the left we just remain with dy dx, dy dx 4 cos x cos y is equal to, then when this goes to the other side of the equal sign, will become 4 sine x sine y. Yeah, and then from there we can divide everything by 4 cos x cos y, so that we just remain with dy dx this side. So dy dx will therefore be equal to 4 sine x sine y, then everything over 4 cos x cos y. This is what you're going to have. Hence dy dx will therefore be equal to this, and that will cancel. So when those two, when these 4's cancel, we'll just remain with this part here. But of course, you know, sine x over cos x, the answer is tan x. Same applies to sine y over cos y, the answer is tan y. So you can leave your answer in this format. Still okay. So if I've not made any error when writing these derivatives, this is the answer. Yeah, so sometimes I tend to make some simple mistakes when solving. Instead of subtracting, maybe instead of writing maybe 2 minus 1 is equal to 1, I write negative 1. So you should be observing that. Yeah, but the steps are just okay. Everything is 100% okay. So this is the solution to this question here. So in a similar way, or in the same way I've solved this, you can also solve this, because you know that the derivative of sine x is simply just cos x. The derivative of 2 cos 2y, this is also straightforward. Or maybe let us solve it together, and I think I'll end on this question. For these other questions, you can solve them and then forward the solutions to me. They're simple and straightforward. Okay. Okay, so this one is sine x. Of course, this is letter K. So I'm leaving the remaining questions for you to practice. You can send your solutions to my WhatsApp line. So you have sine x, then plus 2 cos 2y is equal to 1. So if this is what you have, the derivative of sine x is simply just cos x. Then the derivative of this part, remember, using chain's rule, you can differentiate the function there. So when you differentiate 2y, you are getting 2. So let me put a plus there. You're getting 2. Then there's this constant 2 there, which I'm going to multiply by that. Then the derivative of cos 2y, the derivative of cos, this function here, the derivative of cos is simply just negative sign. So we maintain the angle there, which is 2y. Then we say this is equal to, of course this one is y, meaning we have to add dy dx here. Then we say this is equal to the derivative of 1 is simply just 0. So we have cos x, 2 times 2, the answer is 4. Then negative 2 sine y, so we have negative 4 sine 2y, negative 4 sine 2y, then we have dy dx is equal to 0. So I'm going to take this cos x to the other side of the equal sign, so that we just remain with negative 4 sine 2y dy dx, or trying to make dy dx the subject. So this will be equal to negative cos x. Then to make dy dx the subject of the formula, you can divide everything by negative 4 sine 2y. So dy dx will therefore remain as negative cos x. Then everything divided by, you have negative 4 sine 2y. So we can simplify further by cancelling the negatives there. So we have dy dx to be equal to, we have cos x, then everything divided by 4 sine 2y. So this is what you are going to have as the derivative of that. Okay, so this is the solution to this one. So like I said, you can try to solve this one, which is also straightforward. Don't look at pi to be something I don't know what you think, but pi is just a number. The same way I differentiated this one with 2 there, that's the same way you differentiate these two trig ratios with pi. Yeah, so if you want, you can first expand this and then differentiate the terms independently. But if you want, you can use chain's rule, which is a straightforward way of differentiating. Yeah, you can use chain's rule and then you differentiate everything, then make dy dx the subject of the formula. Same applies to this part. You do the same. Sine x, when you differentiate this one, you get cos x. And then this other part, you can use the product rule, because you know that you're multiplying x and 1 plus tan y. You have two functions, so you can use the product rule to differentiate that part. Then you have cot y. Cot y is simply just the same as cos y over sine y. So you can also use the chain's rule to differentiate this part here. Then after differentiating this part using chain's rule, then you can do as is. You can come and replace it in the equation where you're going to be differentiating this and that as well. So differentiating x is simply just is very much straightforward. With respect to x, the answer is 1. For this one, when you differentiate y, the answer is just dy dx. So you can differentiate this part and that part, and then cot y, you express it in this form. Then you make your u to be equal to cos y, and then your v to be equal to sin y, and then you differentiate everything using implicit, of course. Okay. You also have this differentiating y, you give you dy dx. Differentiating this part, you can, when differentiating this function here, just this part alone, you have to use the product rule. Yeah. And then you also combine it with the differentiation of this, which is dy dx, and then make dy dx the subject of the formula. So same applies to this part here. You can also differentiate x, which will give you 1. You differentiate this one as well, which is sec 1 over y. So sec 1 over y simply just the same as 1 over cos 1 over y. That is sec 1 over y. So you can also differentiate this. If you want, you can use chains rule. If you want, you can use quotient rule. You still get the same answers. Alright. Thank you very much for watching today's tutorial. So if you have not yet subscribed to the channel, make sure that you don't forget. And if you have any questions, feel free to contact me on the lines on the screen. Can contact me on these lines on the screen, and don't forget to subscribe to the channel and click the notification button so that every video that I'm going to be posting should be able to see it. My name is Harmtedy. Shalom, shalom.